In the present video, we will discuss the graphical method for m/2 game with the following example. Let's see the problem. Solve the game graphically, whose payoff matrix for the player A is given in the following table. Here, player A having the 4 strategies and player B having the only 2 number of strategies. So this game is m/2 game model. Let's see the solution. First step is find out the row minimum and column maximum and also find the mini max and maxi mini values. So first we have to find out the row minimum. So row wise we have to find out the minimum values. In the first row, values are the 2 and 4. Among the 2 and 4, minimum value is the 2. In the second row, among the 2 and 3, minimum value is the 2. And in the third row, among the 3 and 2, minimum value is the 2. And in the fourth row, values are the -2 and 6. Among these two, minimum value is the -2. Similarly, we have to find out the maximum values from the column wise. In the first column, values are the 2, 2, 3 and -2. Among these values, maximum value is the 3. And in the second column, values are the 4, 3, 2 and 6. Among these values, maximum value is the 6. So next we have to find out the mini max and maxi mini values. So first we have to look for the mini max value. Mini max mean among the minimum values we have to find the maximum value. So minimum values are the 2, 2, 2 and -2. Among these two, maximum value is the 2. So mini max value is the 2. So similarly, next we have to find out the maxi mini value. Maxi mini value mean among the maximum values we have to find out the minimum value. So maximum values are the 3 and 6. Among the 3 and 6, minimum value is the 3. So maxi mini value is the 3. So here mini max value is the 2 and maxi mini value is the 3, which is 2 is not equal to the 3. So given game is not having the saddle point. So game is no saddle point. Let's see the second step. Let's consider y is the probability of selection of alternative 1 by player B and 1 minus y is the probability of selection of alternative 2 by player B. So here player B having the 2 strategies. Let's consider y is the probability of selection of the first strategy. Similarly, consider the 1 minus y is the probability of selection of the second strategy by the player B. So next derive the expected gain function of player B with respect to each of the alternative of player A. Then find the value of the gain when y equal to 0 and y equal to 1. So for this, first we have to draw the tabular column like this. And here, first column is the A's alternatives. So player A having the 4 strategies, then have to write down the all the 4 strategies. That is the 1, 2, 3 and the 4. So next we have to look for the second column, that is the B's expected payoff function. So we have to express the payoff values in the terms of y. That is, in the first row, B's expected payoff function will become the 2 into y plus 4 into 1 minus y. This value which is equal to the 4 minus 2y. So next we have to look for the second row. In the second row, B's expected payoff function will become the 2 into y plus 3 into 1 minus y, which is equal to the 3 minus y. So similarly, next we have to look for in the third row. So in the third row, B's expected payoff function will become the 3 into y plus 2 into 1 minus y, which is equal to the 2 plus y. So in the fourth row, B's expected payoff function will become the minus 2 into y plus 6 into 1 minus y, which is equal to the 6 minus 8y. So next is the B's expected gain values when y equal to 0 and y equal to 1. So substitute the y equal to 0 in the 4 minus 2y. Then B's expected gain at y equal to 0 value is the 4. Similarly, I have to substitute y equal to 1 in the 4 minus 2y. Then B's gain at y equal to 1 is the 2. So next second one is the substitute y equal to 0 in the 3 minus y. We will get the 3. And substitute y equal to 1 in the 3 minus y. We will get the gain value is the 2. And next we have to substitute y equal to 0 in the 2 plus y. We will get the gain value is the 2. And substitute y equal to 1 in the 2 plus y. We will get the gain value is the 3. Similarly, we have to substitute y equal to 0 in the 6 minus 8y. We will get the gain value is the 6. And substitute y equal to 1 in the 6 minus 8y. We will get the gain value is the minus 2. Next step is the plot the gain functions on a graph sheet by assuming a suitable scale. Keep the y values on the x-axis and the gain values on the x-axis. So here you have to represent the gain values, that is the 0 and 1 with suitable scale on x-axis. Similarly, we have to draw the y-axis with the gain values with suitable scale. Here gain values range is the 6 and minus 2. So we have to represent the gain values on the y-axis within the range of the 6 to minus 2. So we have to considering the 1 centimeter equal to the 1 unit, and we have to mark the y-axis up to the 7 in the positive side and mark up to the minus 3 in the negative side at y equal to the 0, as well as we have to draw the at y equal to the 1 also. So next we have to mark the gain values 4 and 2 for the first strategy of player A on the y axis at y equal to 0 and y equal to 1. So we have to mark the 4 at y equal to 0. Similarly, we have to mark the 2 at y equal to the 1. Next, we have to join these two gain values by the line L1. Similarly, next we have to mark the gain values 3 and 2 for the second strategy of player A on the y-axis at y equal to 0 and y equal to 1. So mark the 3 and 2 at y equal to the 0 and at y equal to the 1. Next we have to join these two gain values by the line L2. Next we have to mark the gain values 2 and 3 for the third strategy of player A on y-axis at y equal to 0 and y equal to 1. So mark the 2 and 3 at y equal to 0 and at y equal to the 1. Next to join these two gain values by the line L3. So next we have to mark the gain values 6 and minus 2 on the y-axis at y equal to 0 and at y equal to 1. So mark the 6 at y equal to the 0 and mark the -2 at y equal to 1. Next, we have to join these two gain values by the line L4. So next we have to find the lowest intersection point in the upper boundary of the graph. So this is the upper boundary of the graph. So this is the region, upper boundary of the graph. So first we have to identify the upper boundary of the graph. So this is the upper boundary of the graph. So here intersections points are, these are all the intersection points. So have to identify the intersection point in the upper boundary. Among the intersections, we have to identify the lowest intersection points. So that point we are calling as the mini-max point. So here observe the, first we have to mark the all the intersection points. Here these are all the intersection points. So among the all the intersection points, we have to identify the lowest intersection point. So lowest intersection point is this is the lowest intersection point. So this is the lowest intersection point, and this point we are calling as the mini-max point. So next step is, so we have to observe the how many lines are passing at the mini-max point. If the number of lines are passing through a mini-max point is only 2, then we have to form the 2 by 2 payoff matrix. So here, so this is the our mini-max point. Here only 2 lines are passing. So that is the line L1. This is the line L1. It is passing, and similarly this is the line L3. So line L1 and line L3 is passing through the mini-max point. Then we have to form the only these two strategies by the 2 by 2 payoff matrix. So here line L1 and L3 are passing at the mini-max point. Then we have to consider the strategies for the player A is the 1 and 3. So we have to considering the 1 and 3 strategies for the player A. Now the payoff matrix will become the, so player A having the only 2 strategies, that is the A1 and A3. Similarly player B having the only 2 strategies, that is the B1 and B2. And its gain values are the 2, 4 for the player A first strategy, and 3 and 2 for the player A third strategy. So next step is, let's consider the P1 and P2 are the probability of selection of the alternatives for player A, and Q1 Q2 are the probability of selection of 1 and 2 alternatives for the player B. So let's consider P1 and P2 is the probability for the selection of the first strategy and the third strategy. Similarly, I have to consider the probability Q1 and Q2 for the selection of alternatives 1 and 2 by the player B. And we know the formulas for the P1, P2 and Q1, Q2. So here A11 and A12 and A22 values are the, A11 is the first row and the first column value, that is the 2, and similarly A12 first row and second column value A12 is the 4, and A21 second row and the first column value A21 value is the 3, A22 second row and second column value A22 value is the 2, and substitute these values, we will get the P1 value is the 1 by 3 and P2 value is the 2 by 3. Similarly, you have to substitute this A11, A12, A21 and A22 values. We will get the Q1 value is the 2 by 3 and Q2 value is the 1 by 3. And also we know the formula for the value of the game, that is capital V. Substitute these values A11 and A12, A21 and A22. We will get the value of the game V equal to the 8 by 3. Then the solution of the given game is the player A chooses the optimal mixed strategies, that is A1, A2, A3 and A4, and its probability is the 1 by 3 for the selection of the first strategy, and he is neglecting the second strategy, so it is the 0, and probability for the third strategy is the 2 by 3, and fourth strategy is neglecting, so its value is the 0. So the player A chooses the optimal mixed strategy is 1 by 3, 0, 2 by 3, 0, and player B chooses the optimal mixed strategy, that is the 2 by 3, 1 by 3, and value of the game to the player A is the V equal to 8 by 3. So this is the solution, and thank you.